we have a very competitive system. Look at the water quality in our competitors in Europe, and we're ahead of them, We can be ahead of the game in all this. We can be the leaders in this. I think high profitable grass-based dairy farming can coexist with high water quality. That's my view.
I'm joined this week by Pat Dillon from Teagasc to discuss the Better Farming for Water campaign. Water quality continues to be a major focus for the agricultural industry. And while farmers are already making changes at farm level, there's increasing emphasis on how practical actions can improve water quality outcomes at catchment level. In this episode, Pat explains what the Better Farming for Water campaign is aiming to achieve, why a catchment approach has been taken, and the practical actions farmers can take to make a difference. We also discuss concepts such as nitrogen use efficiency, nitrogen surplus, stocking rate, and how all of these interact with water quality. I started by asking Pat to tell us about the Better Farming for Water campaign and what it's aiming to achieve.
It goes back to 2024. The then Minister asked Teagasc to lead a multi-actor advisory campaign to improve water quality, where agriculture was the main pressure. So that's really important. It's multi-actor. It's an advisory programme. So in response, Teagasc launched the Better Farming for Water campaign, 8 Actions for Change, and all initiatives were really about sustainable practices at farm to reduce nutrient loss like phosphorus and nitrogen and sediment from water to improve water quality. That was it. So, if we talk about then good or high ecological, that's what the EPA measure are important. From an environmental point of view, we have to take it that a healthy ecosystem to support, fish and insects and plants in rivers is really important. But poor ecological status water is represented by water bodies that have a high level of eutrophication or pollution from excess nutrients, P and K and sediment, and that's where we are. And if we look at it then, where is it coming from? It's coming from the Water Framework Directive, the EU, which has set a target that all water bodies would be either good or high ecological status by 2027. And currently in Irish surface waters, just over 50% are good or high. But if we look at the average proportion of water bodies in the EU is 27, 37% are of high or good. We're ahead of the average, within Europe. But that's not saying we still need to improve where we are. And I think, and the message will go through for me, I think there's real opportunities to improve that.
There's already a number of programs, I suppose, focused on improving water quality. What makes this program, Better Farming for Water campaign, what makes it different and what does it look like on the ground?
Yeah. And it's a really good question. And I think there is a justification for it, right? Like we have existing water quality programs like the ASAP, the Farming Water EIP, the Water for Life, and other actions. And yes, they're important. And this program is not replacing that. But this program has a coordination role in bringing all these together and to have real impact, So, and the way it's structured is really important as well. We have a steering group which is based out of Teagasc headquarters, and we're working on a catchment basis, and at each catchment then we have a catchment implementation group. And that group consists of an independent chairperson and a catchment-based representative agri-food sector taking the lead on that. But in the context of all that then, within that implementation group at any one catchment, and take the Blackwater, for example, DII, MII, THI are involved, farmers are involved, really important. Regulators are involved, in Law Pro are involved, the local authorities, and of course ourselves as an advisory thing, and linking to ACA too. And the wider community then buying in. So if we take in just the Blackwater as an example, and we have them all set up now, we have 7 action programs, and we launched all those over the last month. And the last one was the Carberry, was the Bandon Lee one last week. But if we just take the Blackwater, for example, we have an independent chair, and that's Kevin Toomey, a well-known dairy farmer. He chairs the implementation group, and really the implementation group oversee the programme in the Blackwater catchment. The lead industry there is Dairygold, and they take the lead in that. We have other industries taking a lead. We were talking about in the Bandon Lee, it's Carberry. If you take it in the Barrow, it's Tillage Industry Ireland. If you take it in the Nore, it's Dawn Meat. So we have 4 led by dairy industry, 2 led by 3 led by beef and 1 led by tillage. So that is really important that we get all the thing. And then what Teagasc input in is we have a coordinator appointed to each of those catchments. If we look at the Blackwater, that's Philip Murphy. So the important thing, the purpose then of the Blackwater Catchment Action Plan, now we have an action plan published in each of those launches. That's really important. We have all the information on water quality in the catchment. And the objective then is to improve. So in summary, then it gives control back to the river catchment to implement the local people to implement the program. Getting all the local industry involved I think is really important.
And why, I think that's an important point, and that's the basis of this program, Pat, is the catchment-based approach.
Yeah.
Maybe talk to me, why is that so important?
Yeah. I was in New Zealand a couple of years ago, and I saw this at the catchment level, and all their water quality programs are based off a catchment. So why a catchment then? A catchment is take the Blackwater, it's a distinct geographical area. You have a river flowing through it. You have tributaries flowing into it. But the water quality in that catchment is representative of the farming practices that are happening in that catchment. That's important. So you're focused. The other feature is that one size doesn't fit all. Catchments are very different in terms of soil type, farming systems, weather and climate, how all an impact on water quality. Just one, that's why you can't go nationally on one program, that is.
You mentioned there in terms of each catchment is different. Like, is there unique features within each of those catchment that kind of make them different? And ultimately then you kind of maybe have a different set of management practices how you actually deal within each catchment.
So if we take the Slaney as one, right? The Slaney is a very free draining soil. It's not an intensive grassland dairying area, it's more tillage area. Its ecological status is quite good, actually. About 62% of the water bodies are of good ecological status. That's the water bodies. But the problem in the Slaney is the nitrate level in the water in the Slaney is excessively high. It's over about 4.5 milligrams per litre. And that is, high nitrogen is affecting the estuary in Wexford Harbour, and it's poor ecological status in the estuary, right? So phosphorus is not an issue in the Slaney. Phosphorus levels actually are the phosphorus level in the Slaney would produce, the level is, I think, is 0.025 or something. It would maintain good water quality. So that is why then the ecological status of the rivers in the Slaney is quite good, because phosphorus is the main thing that affects the river. Nitrogen is the main thing that will affect the estuary, but the estuary is poor. So sand in the Slaney needs it. So that's just the Slaney, for example. Then if you just backed into Blackwater, Blackwater is very different. It's pasture-based system. It's a combination of sides then in the western part you have heavy size and the eastern part you have very free draining side. Again, the ecological status is very good, but again, the nitrogen, the phosphorus level has come down in recent years. And if we look across Europe, phosphorus is the main issue that's affecting water quality, that's causing poor water quality. So it's nitrogen there again. So if you take the binding up beside you, only 28% of the bindings river water bodies are of good of high, only 28. And the big issue there is around phosphorus. There is nitrogen issue too, but you would say phosphorus is the biggest issue. So the plans you put in place, the mitigation you put in place will be very different whether it is nitrogen or phosphorus is your main issue.
The metrics used, you've mentioned in terms of really what we're looking at there. It's nitrates, it's phosphorus, and it's the biological status.
So, right, ecological status is the end product, right? That's the end product, and that's what the EPA monitor, and they do a third of the water bodies every year, and they produce the report back in 2025, and it's over 3 years, and they show that. But what is affecting then ecological status? It's nutrient overload. It's if it's bad ecological status, it's either high phosphorus or high nitrogen, or a combination of high phosphorus and sediment that's around. So the actions will be very different. And the EPA have all the data and that they have the pit maps in to show you that in certain size, phosphorus is the main issue. And the mitigations you put in for phosphorus will be totally different, as I said, for nitrogen. And it's overrun flow is the main issue. So mitigation, repairing margins, anything that would stop nutrients flowing. Nitrogen is totally different. Nitrogen is leached through the soil. Uh, it's a light soil problem. Typically occurs where excess nitrogen is applied and above requirement. So high nitrogen is, as I said, is mostly in free draining soils in the south and the southeast. So that's why, yeah. So excess in sediment can impact conditions like ecological habitats, and fish, and sediment. One example of sediment now in heavy soils would be, and we come to the 8 actions for change, is not having waterways fenced off from animals. And you get sediment in, if animals go into the river, you get sediment and you get all the negative effect in terms of the whole ecological status of that river, you know.
You have actually probably covered some of it there, but maybe how farming practices influence these water quality indicators.
We have identified the 8 actions for change as part of this program.
Hmm.
And we talk about nutrient management first. You talk about reducing nitrogen surplus. You talk about optimizing soil fertility and applying fertilizer at the right rate, the right time, and the right conditions. So they're all practice changes that we need to. On the farm management, on farmyard management, we talk about having enough of slurry storage. And we saw the issues this spring in terms of slurry storage, minimizing pine sourced in from yards and that. And then on the land side, is land management. We talk about fencing off water courses to prevent animal access, and using riparian margins and buffer strips and that to prevent overland flow, especially in heavy soils. And then on the tillage land, it's maintaining overwinter green covers on tillage land, and the research has shown this is very positive. So they're all practice changes. And you would say any farmer that you'd walk into in the morning, there's one of those at least, if not two or three of those, that need to be addressed. So improving water quality is for all farms. All farmers have a role in terms of improving water quality.
And that's important. And I'm going to pick up on maybe a couple of these because there's new metrics and there's new we'll say terms that maybe farmers wouldn't be as familiar with. The grassland ones come easy, Pat. The breeding ones, they're well ingrained.
Yeah, yeah,
But we'll say if farmers are hearing more now about metrics such as NUE or nitrogen use efficiency, and you mentioned one there, nitrogen surplus. And I think
yeah,
often maybe there's confusion as to
yeah,
the difference between the two of those.
yeah.
So can you maybe explain
Yeah.
NUE versus N surplus?
Okay. I think nitrogen surplus is a better measure, anyhow, parameter to use going forward. But anyhow, I just talk about both of them then. So in a grass-based system, nitrogen use efficiency, or NUE, is the proportion of nitrogen that is imported onto a farm. It's the proportion, the percentage.
Hmm.
And most nitrogen comes in either chemical nitrogen or concentrate nitrogen that is converted into milk and live weight that goes out the farm gate. It's a percentage.
Yeah.
And a good percentage for farmers would be, say, greater than 30%. So on a grass-based system. So NUE of greater than 30%. Then if we talk about surplus then, and surplus is measured in kgs of nitrogen per hectare that is left over in the farming system after accounting for both the nitrogen that's brought in again on the farm in terms of chemical and concentrate, minus what is export, and it's done on a per hectare basis, and it's done in kgs. So a good nitrogen surplus, and the nitrogen surplus would depend on the stocking rate. So a good nitrogen surplus for me, say at 2.2 cows per hectare, would be about 140 kilos of nitrogen surplus per hectare. Both of them are important. I think it should be driven by the surplus kgs per hectare with a target NUE. That's my view.
Is that for the reason, Pat? I suppose the surplus is an actual kgs figure. The percentage
Yes.
maybe doesn't tell you all the story
Yes.
in terms of it doesn't give you the
Yeah.
actual surplus loading. So that's the difference maybe between the two, and that's why maybe you said, Pat, at the start of
Yeah.
that answer that surplus is possibly the one we should be looking at. and reducing that
Yeah,
overall end
yeah,
loading.
yeah, yeah,
Talk
yeah.
to me about stock and rate because it comes into the
Yeah.
conversation obviously an awful lot. How does stock and rate influence, we'll say,
Yeah.
those metrics, and how can a farmer improve their nitrogen surplus, we'll say, at a given stock and rate?
So generally, nitrogen surplus increases with stock rate, but that's not the full story. When we analysed the National Farm Survey data, we showed that the highest 20% of nitrogen surplus at 1.5 cows per hectare was the same as the 20% most efficient dairy farmers, the most efficient at 2.5 cows per hectare. So
Mm.
it's not all following on stock rate. But there's a financial consideration in all this as well, you know. And it's all about reducing the surplus. So our view going forward is it requires all farmers to reduce the surplus immaterial what stocking ratio are. And that will achieve what we want to achieve. Because based on, you can calculate back to what the EPA say in terms of reductions in kilos of nitrogen, losses to the river we need. That is the way to do it, you know.
And
So,
to come to just dig into that a little bit, Pat, in terms of if you look at, we'll say those farms stocked at 1.5 versus the most efficient farmers from an end surplus perspective, stocked at 2.5. What practices are they carrying out, Pat, to ensure that they're reducing their total end surplus on a per hectare basis?
to me, there's five main things that drive nitrogen surplus. There's the chemical nitrogen application per hectare. There's the concentrate fed per cow. There is the crude protein in the concentrate you're feeding, especially in the autumn.
Mm.
There is the soil fertility of your farm. And there is the organic N, how well you're using the slurry N in your farm to replace chemical nitrogen. So, I mean, if you do the calculations and what you wanted to reduce, whatever you want to reduce by, you could reduce nitrogen surplus without ever reducing chemical nitrogen by, say, I think when I looked at it, say at 2.5 cows per hectare, if you reduce 400 kilos of concentrate, you'd reduce nitrogen surplus by about 25 kilos per hectare, which is very
Mm.
significant, you know. Like you would change the crude protein then from, I don't know what I was looking at, it, something from 18 down to 13% crude protein. You could reduce your nitrogen surplus at a given stocking rate, it's about half of that. And then the site fertility is really important. And I would highlight the lime, you know. I mean, the New Zealanders showed that actually at high stocking rate, your nitrogen surplus can be lower. And actually they showed it in terms of water quality because they were utilising more grass. So they were pumping more of the nitrogen out the farm gate.
Mm.
So having a
Yeah.
very efficient system is also really important. Yeah, and the other one then is making better use of our slurries for nitrogen purposes, you know. So that entails then practice change in terms of how we use slurry on farms. And it's not all put out in January, February, and the nitrogen is not utilised very inefficiently, you know. So
I think
they're
that's an
all,
important and as important point, Pat, and that it often gets, as you say, stocking rate gets tangled up with higher stocking rate associated with issues with water quality, but you very clearly there show that it's very much practice related as well. Stocking rate alone doesn't tell the whole
that's
story, and
right.
that and it's a key point in the whole conversation around water quality. Uh,
Like I'm convinced that we can achieve improved water quality while at the same time maintain profitability at farm level, and they're both important objectives, you know. And you can achieve both. You can maintain good high profitability and put some of these actions in place, and they have no impact. And that's what our analysis showed: no impact on farm
And
profitability.
even look at a
But
lot of those actions you've actually spoke about are going to have a positive impact on the financial side of the house in terms
yes,
of
exactly.
improving soil fertility,
Yeah, yeah,
making better use of chemical nitrogen, making better use of the slurry available on farm. All those things are going to have a positive impact from an economic point of view as
yes,
well.
yes, yes,
There's a couple of things. I wanted to pick up on. One of them is, I think, in fairness, the vast majority of farmers acknowledge that, agriculture has a role to play in
yeah,
improving water quality. Frustrations, Pat, maybe often arise where issues can be linked at points to other sources, we'll say, rather than farming. Can these different sources be identified and we'll say separated out from agriculture, that you're going in now to work in these catchments that you can clearly see in terms of where management practices are implemented at farm, that they have a positive impact on the influence of agriculture in the region?
I'm not going to say that agriculture is the only thing that needs to change practices, no doubt about that. But if we look at it and there's no, well, we are looking after agriculture, and I think it's still important. But if we look at it anyhow from a national point of view, like agriculture dominates our land use in Ireland, so about 40%, about 70% of our land use. Therefore, it's not surprising that agriculture then is identified as one of the main threats. So if we look at how the EPA measure it, they say nationally agriculture is identified as the most prevalent significant pressure in approximately 62% of the water bodies that are at risk to water quality. However, it also says, even in those catchments, however, 2/3 of those water quality, the water being where agriculture is a significant pressure. Additional pressures have also been identified, whether it is wastewater, whether it is forestry, whether it is hydromorphology, whether it is septic tanks. The EPA can separate out the impact of the different pressures, and I think that if I said that we had nothing to do and that all our practices were 100% right in terms of water quality, I say fine. But I think there is practice we can change to improve, and will have an impact on water quality. And that's why there's no point in talking about other people.
I was going to say we control what happens within the farming and ag sector, and we make sure our body of work is carried out there. If you were speaking directly, we'll say, to dairy farmers, Pat, what are the practical actions? You've mentioned some of them at farm level that will make the biggest difference to water quality. Is there 2 or 3 or 4 that you'd say now we're into April, Pat? We're moving through 2026 probably at a pretty quick rate. What things can farmers do this year, next year, long term, short term? What are they?
So there's 8 actions there. Any farmer that sit down tomorrow morning to look at it, which actions? The actions will be different for different farms. If you're a tillage farmer, it is about sowing cover crops over the winter. It's a talk about using buffer strips in the farm. They'd be the 2 big, really important ones. If you look at dairy farmers, you'd say farmyard, enough slurry storage where you can improve nutrient efficiency. Pine source from farms is still a big issue. I mean, our surveys show that. Improving soil fertility. If you look at dry stock farms, no doubt about it, fencing waterways from cattle is a really important thing. It's illegal in some countries to give cattle access. Most of that then is on heavy soils and there is real opportunities of minimising overland flow, especially phosphorus, into water bodies on those farms. So they all have, they all have a role, The thing is for a farmer to sit down is, what can I do to do it? And then put those in place. That's my view,
What's the ultimate goal, or what's the prize from all this, both for farmers and also from the wider industry?
Again, we have a more sustainable system. We have a very competitive system. We have, from a marketing point of view, we can stand over. I think, look at the water quality in our competitors in Europe, and our competitors now I talk about and we're ahead of them, We can be ahead of the game in all this. We can be the leaders in this, I think. And I think we can, high profitable grass-based dairy farming can coexist with high water quality. That's my view. And that's where we have to get,
My thanks to Pat Dillon for joining me on this week's show. Don't forget to rate, review, and subscribe to the podcast. You can listen on Apple, Spotify, or wherever you get your podcasts. For more information and to access the 8 actions for change, visit the Teagasc website at www.teagasc.ie. I'm James Dunne, and join us next time for Your Dairy Edge.